Hi, and welcome to this video on factoring polynomials using the GCF. Well, we've talked about the GCF and what it means. We know that it stands for the greatest common factor. Okay, so if the GCF stands for the greatest common factor, what does that mean? Well, we know that factors are two numbers that you multiply together in order to get a product, correct? Okay, so then the greatest common factor would be the factors that two products have in common. Okay, so for instance, if I have the numbers 4 and 24, well, the largest number that they would have in common, they're both divisible by 4, right? 4 is divisible by 4, and 24 is divisible by 4. Well, there's other factors of 24, for instance, 8, but we can't take 8 and we can't take 4 and divide it by 8 and get an even number. So we want to get whole numbers as a result of division. Therefore, 4 would be the GCF of 4 and 24. So if we divided 4 by 4, we'd get 1, and if we divided 24 by 4, we'd get 8. And so those are both whole numbers, right, that we get as a result of dividing. Okay, so that's kind of what we're looking for, is we're looking for the greatest common factor that we can divide either term by and still get whole numbers. Okay, so unless we're dealing with fractions, of course. So now let's look at number 1. Okay, so we're looking at a binomial. We're looking at binomial terms here. And that means that it's two binomial expressions that have basically been added or subtracted. Okay, so each binomial expression, 4x and 12, are terms. We've learned that before, correct? So we want to find the greatest common factor between these two terms. Well, we have 4x and 12. Well, in one term we have an x and in the other term we don't, so we won't have any factors of the variables because they both don't have variables. But we do have, they both are divisible, their coefficients are both divisible. So for instance, 4 is divisible by 4 and 12 is also divisible by 4. 12 and 4 are also divisible by 2. However, 2 is not the greatest common factor because we can also divide by 4. So 4 would be the largest number because 4 is the largest thing that will go into 4, but 4 will also go into 12. All right, so when we do that, we said that our GCF is equal to 4. So now we're going to divide the entire monomial expression by 4. So one way to do that is to bring 4, your GCF, as a factor. And so now we're going to find the other factor that we multiplied by in order to get this expression up here. Okay, well, to do that, let's go ahead and divide 4 divided by 4. Okay, well, that's 1. And so I'm left with just x. And then 12 divided by 4 is, there's a plus sign between them, and 12 divided by 4 is 3. So what I get is 4 times x plus 3. Okay, so that is those are my factors that I multiply in order to get this. And if you look and we redistribute by multiplying the 4 back out, we would get 4x plus 12, which will be the expression that we started with. Okay, let's try number 2. Let's look at the GCF. Take a second and find it. You can pause the video if you need to. Okay, if you guess that it was 2, that is correct, because 16 is divisible by 2, and 2 is divisible by 2. However, if you try to use 16, well, 2 is not divisible by 16, not at least if you're trying to get a whole number, right? So the largest whole number that we can get by dividing them by a common factor would be to divide them by 2. Okay, so basically 2 is the GCF, and so I'm going to divide the entire expression by 2. So 2 is now going to become one of my factors. That's my greatest common factor. And so 16 divided by 2 would be 8, and don't forget to bring down your x. And then 2 divided by 2 is 1, and there's a minus sign between them. Okay, so since you're only dividing by 2, nothing happens to the x, right? Because it would kind of be like x to the 1 minus x to the 0, which would be 1. So basically you're just dividing x by 1, so it stays x. Okay, if there were another variable in your GCF, then of course you would divide the x by that variable using your rules for exponents. Okay, and we'll try one of those in the next example. Okay, so far we have we have 2 times 8x minus 1, and so this would be our two factors. These would be our polynomial factor. And if we multiply those back out, we get 16x minus 2. Okay, so now let's try this one. Well, here we have 4x squared and we have 24x. So we have numbers that have a common factor in both terms, and then we also have variables that are common in both terms. So what we want to do is find the greatest common factor. Well, one way that we can do that is we can start with the numbers first. So maybe if you're not a person who can immediately look at variables and numbers and see all the factors together, well, then you can pull them out step by step. So first, let's pull out the numbers. Well, if I pull out a 4, right? And then if my GCF between the two numbers is 4, and that looks like the highest number, then basically I can take 4 and divide it by 4, and I would get 1. And so I would also bring down the x squared. And then I would also take 24 and divide it by 4, right? And so there I would get 6. So that would be minus 6x. Well, I still have some factors in there for x. So I'm going to come over here, and now I'm going to factor out. It looks like since I have one x in one term and two x's in another term, the most x's that I could divide by would be 1x, right? Because x is divisible by x, and x squared is divisible by x. However, x is not divisible by x squared, at least not evenly. So therefore, x is my GCF also. Okay, so now I'm going to go ahead and go back and divide both terms by x also. So what I end up doing is dividing the whole expression by 4x. So now let's take x squared and divide it by x. Well, remember our rules for exponents is that if I have x squared divided by an x, that's x to the second divided by x to the 1, so it becomes x to the 2 minus 1. Remember that we subtract the exponents when we use the quotient rule for exponents, right? If we're dividing two exponents with the same base. So I'm going to end up with 1x, and in this case, this will be x to the 1 divided by x to the 1, so this would be x to the 1 minus 1, which is x to the 0, and anything to the 0 power is 1, right? So I have minus 6 because I basically took that x out. Okay, so what I have here is I have 4x here, and I have x minus 6 here. So my term will be 4x times x minus 6. Okay, so if you need to do that another way, let's try that as well. So I'm going to come over here and work that one out in a traditional way. So we have 4x squared minus 24x. And so maybe you recognize immediately that that 4 is the greatest common factor between 4 and 24, and x is the greatest common factor between x squared and x, okay? So if you want to look at it in this way, well, when you look at it, when I'm writing my factors, I'm going to bring my GCF out of the brackets, and so I have 4 and x. Well, how come we chose x? Well, since x is the least amount of x's that you have, the most that you can pull out of any term is one of them, right? So I have 1x in this term and 2x's in this term, so the most x's that they could have in common is 1, because one of the expressions has 1x and the other expression has 2x's, okay? So if I pull out 4x, then basically I'm just taking this each term and dividing it by 4x. That's what's happening, and so what I get in the brackets is a result of that division. So 4 divided by 4 would be 1, and x squared divided by x would be x, and then 24 divided by 4, there's a minus sign between them, that would be 6, and x divided by x would just be 1. So my final expression is 4x times x minus 6. Okay, and notice also that if I redistribute that 4x, that would be 4x squared minus 24x.